for those of you who are working directly in game audio, I've got some information here that hopefully you can take back to your studios and put to work today to at least inform that conversation about spatial audio. And for the other two guys who aren't directly involved in audio, this might help kind of start the conversation back at your studios as well. Hopefully you have some good stuff to take back. I'll apologize that this isn't in French. My French is, I'm not sure how else you say this, abysmal. So I'm going to work in English. If you want me to slow down, just raise a hand and let me know. The other thing I'll tell you is I'm working two machines here. So if I screw that up and I get out of sync, just wave, point, laugh. I'll fix it, okay? Cool. All right. So what I want to do in this talk is really kind of lay out the Windows Sonic and how that delivers spatial audio to the Dolby Atmos format. All right. So Windows Sonic is really the new spatial audio platform that Windows has put out, and it works on Xbox and PC, and we'll talk about that through this and how that delivers to Atmos. Again, if I go too fast, just let me know. I've had a lot of caffeine, so it could happen. So first, let's talk about this black magic that is 3D audio. We've been chasing this for years, and we could call it all kinds of things. We could use all kinds of overblown language to talk about 3D audio, but at the end of the day, it's simply this. It's a set of cues that inform the user about the space they inhabit in a virtual environment. Pretty simple, right? It's just informing the picture that you get. I mean, there are two ways you could provide this. You could either A, take a speaker and put it in the exact place that you want a sound to come from, and hey, you've simulated reality, good for you. The reality is we don't have speakers all over the room, and I doubt we're going to get many gamers to rearrange their entire living room to make it match the mix that we've put out. So realistically, and you guys probably already know this, we don't have the speakers where we need sound to originate, so we rely on things like psychoacoustic effects and panning to simulate physical placement instead. Attenuation, filtering, we try to make those fixed channels sound like they're completely surrounding us, and we do a pretty good job of that today. So, this is an important thing. I think 3D audio is really very important for telling the rest of the story because it helps fill in what else is going on off the screen. It helps create this, and you'll forgive this too, this immersion that we're looking for. I know you've heard that 3,000 times in the last 36 hours, so I won't say it again, and if I do, you can throw something at me. It's cool. So, visuals can only give you a restrictive field of cognizance, right? You can only see to about 90 degrees, and after that, you start to get pretty seasick, or at least I get seasick. I think, younger ones are getting used to it, but old guys tend to start throwing up after 90 degrees happens. So audio can help fill in the rest of that picture for your visuals. I mean, really, sometimes some of these games can really do a better job letting you know where these cues are, where events that you need to pay attention to via audio instead of stealing focus from the visuals and forcing you to acquire something else somewhere else in the room. And this is all leading to something you're all very familiar with, VR and augmented reality, right? Without those two technologies, I'm not sure if we would have gotten to the point that we are with the need for spatial audio. So VR and augmented reality, I think people have been beating you over the head with that for the past 36 hours too. So again, I'll leave that to people who know how to talk about it better. But that's really helped inform some of the work we've done in spatial audio. So it's working so well. Okay, good. So in the history of this, like I said before, we've been trying to deliver 3D audio for years and years. And in the past, that's generally meant that we sprinkle emitters around an environment, basically, and we pan those through speakers. And on top of that, we'll add psychoacoustic effects like HRTF. You guys know what HRTF is, right? For the rest of you, basically, it's about how sound does different things to our ears, right? I've got these big taxi cab ears here, and I hear something over there. I hear it here first, bends around my head, and it gets to the other ear. And by virtue of that delay between ears, I know that sound came from over there. We developed this at 5 months. So before we're born, we really learn how to interpret an environment using our ears and how to deal with that delay to understand where things are coming from. So using that differentiation and delay, you sound designers do a great job of making the gamer or the player actually perceive motion and perceive position and directionality by using, the tricks that you always have. And I say tricks in a flattering way, not in a playing tricks on us, not the case at all. And really, that captures the last 20 years of audio research and audio acoustics. For the past 20 years, we've been using panning on a horizontal plane, and designers have been doing a great job of using these tools to their fullest. Games sound pretty great, especially over headphones. And so Dolby, in the past, we've had a solution for delivering this more immersive, oh God, I said it again, who wants to throw something? Good, nobody. We've done a pretty good job of getting one technology out there called Dolby Headphone. And it was pretty good. It did a great job of delivering really precisely positioned audio, through headphones and only through headphones. And there was the gap, right? We couldn't replicate this in a home theater. It just didn't work. It didn't have that same spatialization. It didn't sound as good. there was no height. So I could pan a helicopter through an array of speakers and it would sound great, but it was here and it wasn't here, which is creating a little bit of a dissonance for any user out there. And users learned to deal with that. Sound designers learned to deal with that too, and we moved on. It's fine. But no matter how many channels you had, you never could deliver height. And in a larger sense, very little of the content that was out there delivered in Dolby Headphone as well. So you could have this nice headphone solution for games, but then movies broke that experience, or TV broke that experience, or streaming broke that experience and brought it back to stereo. So again, dissonance, users said, it's just for games, and they left it alone. And what's worse, it was hard to implement. So, we could license you the technology. Game companies would license it, they'd train themselves to use it. Then they had to train the users, and they had to hope that the users got it right. Otherwise, they suffer tech support calls, and we've all heard about those. And that just kind of created this cycle of kind of pain and implementation that done right, it's great. Done wrong, it causes you difficulty. And really, trying to apply a bunch of effects to that kind of headphone processing got to be difficult. 2 or 3 voices at a time, easy. 10 voices, a little tougher. 50, 100, 150, we're talking nutty here. And it became difficult for people to deal with all the artifacts they had to work with. So finally, the other problem with that, and there's a whole litany of issues with the headphone renderer that we had, despite the fact it worked pretty well. I don't want to tear it down completely. It was still pretty good, but there wasn't any consistency in that experience. You could implement it however you wanted to. It would put out whatever it wanted to, and some were great and some were not so great, and we just dealt with it again. We just kind of worked with it and moved on. But the good news is we've come a long, long way. And, no news to you guys. Two computers. The compute power actually exists to deliver a lot more of this stuff now. On the Xbox One X, I think you have 8 cores at 2.3 gigahertz. You've just got a deep well of resources there. And on the PC, the sky and your budget or the permission you can get at home, really the limit. You can build as much horsepower into a PC as you want, as long as you're willing to pay for the power. And Dolby's been working with ecosystem partners out there in home theater and headphones to start to provide some practical height solutions instead of having speakers arrayed all over the room. We've tried to figure out how to make the things that you already have work and how to have small add-ons that don't require you to rip everything out of the house. And we'll talk about that a little bit more, but what that really brings is home theater in a very straightforward manner. So there's been, a whole lot of innovation that's going on as well. And I think the thing that Dolby and Microsoft in partnership really want to be able to do is allow users to opt in or out of this experience. So if you want spatial, great. It's available to you. If you don't, if you liked plain old stereo before, if you liked mono, by all means, go play in mono. We don't want to tell you what to do. We don't want developers having to rip out their entire workflow and start over with something else. We want to augment the tools that you already have as well. And so, a whole new stack of tools, a whole new stack of setup. Not our game. We want to kind of work with what you've already got out there. You've spent enough on what you've got right now. So as a result, we're working with a lot of the middleware providers out there and a lot of the game engine vendors to add support to the tools that you already use today. And we're trying to supply methods to augment some of your bespoke efforts as well. So if you have your own engines, we have some tools out there for you as well. And I'll talk about those in just a minute. But really back to the foundation of all this, which is Microsoft's spatial audio platform, which is Windows Sonic. And I work at Dolby. I speak favorably about Windows Sonic because this is a technology that helps enable our playback format. So a little more explanation of that. Have you heard of Windows Sonic? Have you started hearing some of the talk about the spatial audio capabilities of Xbox and PC? Good. Basically, Sonic abstracts all these audio objects from an output format, and it feeds it out to Dolby Atmos endpoints. That means there's really no need for a giant matrix of solutions, right? You can just let the system deal with the myriad endpoints that you have out there, and you can work on making sound in 3D space. You can do that with one mix, and Windows Sonic takes care of dealing that to the right endpoint and the right format. So you don't lose any information. Your work is all delivered the way you expect, as best as it possibly can be. Another upgrade, I guess, to spatial audio is that there's virtual surround sound actually built in for free in the mixer as well. So it provides a lot better linear placement for directionality and for positioning. It's much better than previous versions of VSS for games. So right now, your existing content, your 7.1 mixes that you were building 2 years ago, 3 years ago, they can be delivered directly to ears now, thanks to the enhancements of Windows Sonic. So Windows Sonic is kind of that bedrock that we're leaning on. Okay, so that's available today, and it's been available since the Spring Creators update of Windows 10. And I don't know if any of you are fighting with the updates with that, but once you get those updates, it works really great. In a managed IT environment, it can be a little more difficult, but I'll leave my gripes aside. Windows desktop clients, Win32 apps, even though they're 64-bit, they can all take advantage of Windows Sonic. UWP applications can also take advantage of Windows Sonic. And this is available across the entire Xbox One family of products. That's Xbox One, One S, One X, available across the entire group of offerings. And so, while the runtime encoding is pretty important there, the other important thing is the output format for consumers, and that's the Dolby Atmos side of the picture. So Atmos renders spatial audio on a lot of the devices that consumers have today. And that includes TVs, it includes home theater setups, it includes soundbars over HDMI, but it also includes any set of headphones, anything from your cruddy earbuds all the way up to your high-dollar surround sound headphones as well. All of those are still in play. You haven't got to go replace those things anyway. So to be a little bit of a shill for Dolby, and this will only last a couple of slides, bear with me. What is this Atmos thing anyway, besides a pretty slide? Atmos, you've all heard of Atmos, I'd imagine? You've all had that thrown at you at some point. Have you seen a movie in Atmos? Anyone? A couple of you? The theaters are coming up. This will become more prevalent over time. So, anybody played a PC or an Xbox game in Atmos yet? Probably not yet. They're coming. There's a few out right now, but if you get the chance to hear it, you'll find out that this is our new version of surround sound. And it allows us to provide more realistic audio, more realistic spatialization, and a more uniform experience across a range of categories. So it's not just for gaming anymore, which we think is a pretty good thing. It's catching on pretty quickly. And so I have to start back in cinema with kind of an eye chart, and I have to apologize, that image right there is a little bit dated. I can't get to the marketing department fast enough for them to update their numbers. So we'll get to that in a second, but Atmos was introduced in 2012 with Pixar's Brave, the movie about the little sprightly kid, very cute movie. And people went nuts for it. They could hear the little fairies animated overhead and thought that was just an amazing effect. And as a result, this technology has seen the fastest adoption we've seen out of any technology Dolby's ever put out. For comparison, when we put out Dolby Digital for 5.1, just surround sound, years and years and years ago, 23 releases picked that up in the first year. 23, that's pretty good. We're pretty proud of that. For Atmos, we saw 31 in the first year, and it took off after that. So currently, we have more than 2,000 screens, outdated image. We have more than 600 titles that are playing on those screens, outdated image. And more than 150 mix studios dealing with the format right now in Hollywood and other places around the world. And cinemas are leading the charge, and that's a great thing, right? This relationship between traditional media and gaming content actually exists. A lot of the gamers out there aren't buying one setup for gaming and buying another for movies. They're playing all their media through this stuff. So where we can present a really good audio experience in a uniform way across gaming and regular media, that's great. It makes some control actually come into view for all of us on the endpoints. So what the result really is for us, and the thing that we're excited about, is that there's wide support across the home theater ecosystem as well. So at home, they're taking off. Consumer electronics manufacturers are embracing Atmos with more than 75 AVRs out there right now, at least manufacturers. Home theater in a box solutions are coming out every day. So in US, you can get a home theater in a box for about $500 from Best Buy. Set it all up and be listening to Atmos by the end of the day. We have 60 mobile devices out in the world that actually render Atmos signal, which is kind of amazing to me. And if we include some of the regional variations, the spins of those devices, that number goes up substantially. There's more than 250 Blu-ray releases right now that have delivered Atmos to home. Excuse me. And, if you're not a Blu-ray watcher, if we think, disc-based media is going away, could be very true. No worries. The streaming providers are also picking this up. So Netflix, Vudu, Hulu. It's like a tongue twister. Several in China, Orange, Comcast, they're all picking these formats up and they're delivering them on their top tier 4K delivery platforms as well. So consumers are getting a lot of way to enjoy spatial audio in a variety of form factors. And so there's just one more way to look at this, and it's the entry point. If you go anywhere from a $200 tablet all the way up to as much as you could possibly want to spend on a home theater setup, there's a bunch of different ways to get in. So it's easy to think of this as an expensive experience, but we've really gotten very good results working with a larger ecosystem, driving this down to some of the entry points that people carry around with them today. Things they can afford, things they can carry with them, and it's not this elitist, snobby, full 7.1.4 room. It's available in a lot of places. So the thing I'd like you to remember is that consumers have a variety of methods to consume this content. But we're here to talk about games. And so let's talk about games. 2015, we started with Star Wars Battlefront. And then that delivered Atmos over HDMI, and that was a handheld, here's a library, let's make this work. We worked to make that work correctly over PC, and it sounded beautiful. And I don't know if you've played that. If you get the chance, there's nothing like hearing a TIE fighter scream over your head and doing this and thinking, ooh, that's actually working. This is pretty cool. I love that game. I have my gripes. I can't be Jar Jar Binks in that game and just jump into Rocket Wash over and over again. But again, my gripes aside, I'll leave it alone. The rest of the game is fantastic. Battlefield 1 came out the next year. It did the same thing. It was a handheld operation. They didn't have any SDKs or anything. We integrated libraries with them. They delivered it over HDMI. Sounded beautiful, and everything was a pretty proprietary development experience until Blizzard jumped into the fray in 2016 with Overwatch. And Overwatch did some amazing things with spatial audio and with Atmos. And we'll talk about some of that in a minute, but the first thing that they did that really made this a great release is that they offered HDMI and headphone rendering for spatial audio. So now we're reaching this point where anybody with a set of headphones can experience the highest tier audio presentation of this game, and the reviews support that. People play the daylights out of that game and love it. Now, I won't say it's only because of the audio, but I think it's much more, I'm not going to say immersive, it's much more engaging because you can live within the scene. You're inside a sphere of audio in that game. It's a lot of fun. If you get the chance, play it. We're just getting started, by the way. 2017 had a couple more titles like Rise of the Tomb Raider and Gears of War 4. And there's a lot more on the way in 2018 and 2019. We've traveled around the world. We've gotten setups to a lot of the AAA studios out there, and they've all heard the difference, and they're all making the moves to deliver nearly everything that they're going to deliver on Microsoft platforms in the coming years in Atmos or in spatial audio as well, if not both. So lots of games coming, and 2 computers. So Atmos itself. So this is our new approach to surround sound, like I said before, and we deliver this over the codecs that are used today, not codecs. For the longest time, we delivered a channel-based rendering, right? And we delivered 5.1, 7.1, and we made all the codecs available and the processing available for that. But that also included the ability to fold down to a 2-channel or a 1-channel environment as necessary, so you didn't lose any information, and we did pretty good. And we rode that for a very long time, but when we went back to content creators, specifically in cinematic, but also in games, they came to us and said, look, more channels isn't going to do it. Going to 13.1 or 18.1 isn't going to do anything but make me insane. I don't want more channels. What I want is more precision. What I want is the ability to augment the workflows that I have. And I really want to provide the player much more substantial audio cues than just a sound that's kind of close to where it's supposed to be. So object-based spatial audio kind of became the solution that we had. And so what you see here is the approach. So Atmos is a combined approach of a channel-based bed and sound objects too. So content creators can mix in 3D space, they can select hero objects and fly them around the room, and they get full creative freedom to place things where they belong in a mix. And that, we think, is the ultimate in engaging experiences for media and for most all content. Okay. Great, so before, here we were over the horizontal plane, right? Everything was mixed into static channels. That left sound designers to assign discrete sounds to speakers and pan those around to create motion. And that led to compromises. That led to compromises in positioning and accuracy, and some of the things that you had to do to make things sound good enough were kind of difficult. But again, sound designers got very, very good at using the tricks that they had, using the tools that were available to them to simulate reality. But again, there was no really reliable way to replicate height. There just wasn't. We had a technology called PL2Z that was lightly adopted that did okay, but it just gave you overhead in front of you, and it was kind of thin and fake. So it really didn't work very well, and it just wasn't reliable. So also, content had to be mixed specifically for an endpoint. So you deliver a 7.1 mix, and if you bump into 5.1, well, you have to rely on us to fold that down to 5.1, and we had a relatively naive down mix that would happen. It would work, but did it give you the results you were looking for? Sometimes yes, sometimes no. Sometimes it was less than perfect, and again, we said, okay, well, it's the best we can do, and we moved on. So now, here we go. So now we can break away from the hard rules and the fixed rules of a channel-based format instead, and we can start to use objects with real locations in 3D space, and that gives you smoother and more realistic panning. And it gives you a lot of height right along with your surround sound mix too, and that lets you match your on-screen elements, and it helps extend your story beyond the screen, beyond that 90-degree I'm gonna throw up plane that I was talking about before. And as it turns out, height can be kind of a big deal. And I mean height can be a big deal on a couple of levels here. So, adding height to your home could be an ordeal, actually. It depends on what kind of permissions you need at home, whether you own the place, whether you're comfortable hanging speakers from your ceiling. it could be difficult. You could get in real trouble doing this. You could drop a speaker on your head. Worst case scenario, you could get yelled at for weeks. Trust me on this one, if your home aesthetics committee isn't really on board with this idea. So we realized we had to find a middle ground, and what we've come up with is a workaround with some of these speaker manufacturers out there to deliver these combined speakers that do upward firing drivers and forward firing drivers. So back of the speaker, you have two sets of binding posts. One set of drivers goes up, one set of drivers goes forward, and you have two speakers built into one box. And what that does is it pairs with your AVR. Your AVR is capable of managing those levels very nicely to simulate a height plane very neatly, and that's controllable by the user as well. So, you know, by all means, if you're able to get speakers overhead, you'll get great results and you'll love it and it'll sound great. And if you're mixing, we're going to recommend that you do that. But at home, you know, there's no real reason to fiddle around with speakers overhead or the dangers that could bring. And you haven't got to deal with these fussy trusses and stuff overhead. You can actually use upward firing drivers, simulate the experience, and it's great. And in many cases, you know, it's not just one set, you know, two driver speakers. There's also a lot of companies out there making upward firing modules that you can set on top of the speakers that you have right now, using the setup you already own, augmenting it with upward firing speakers, and then change your AVR out to power the whole thing, and you've got a full Atmos setup as well. So yes, it's a little bit of an investment. It's not as big of an investment as ripping everything out and starting over again, which, again, for home permissions, pretty good. All right, so one of the last things about, there we go. Sorry, I've broken my other computer. Here we go. One of the other things that we need to talk about, or I need to bring up, is that we wanted to extend this back to headphones like we did with Dolby Headphone. We had great success with that, as much as we could, but we realized that headphone was that one nexus point where everybody can get into that experience. So we launched an application called Dolby Access on the Windows Store. That's available now for $15 US. It's a one-time fee. You can apply it once. It applies to all the games you have. It's not a subscription. It's a one-time fee. And in setup, this walks users directly through the setup of their device. So, and I'll show you some of that in just a second, but basically it lets people configure their machine, configure VSS, and start playing games. And it's pretty straightforward and simple. And $15 app, we took this approach deliberately. We wanted, like I said before, we wanted consumers to be able to opt in or opt out as they wanted, and this was an easy way to do that. But we also wanted to minimize the cost wherever we could. So, you know, there's three options here. We can license this to game companies, which means you have to increase the charges for your titles, which might get some rather bad press, and we don't want to pass that on. That's not fair. We could require consumers to go out and buy a new set of headphones, and I think you can all imagine how that would go. I can see these, you know, the social media tarring and feathering we would take for that one. So that didn't seem like it was the right way to go either. Well, we decided that if we charge $15 for one time, then anybody can use this. They can carry the app along with them, and it's the cheaper negotiation to actually enable spatial audio. You can spend as much as you want, but at $15, you can get the full experience over headphones. So, you know, we'll hear complaints. We still hear complaints occasionally. This isn't free. This should be free. This is another thing you're charging me for. Okay, I understand that. On the realistic side, a lot of people get it. A lot of people get it. So we've been able to deliver 2 million downloads of this now, and we haven't even started marketing of it yet. And it's got a rating of about 4.75 stars, and something tells me we're going the right direction. I don't know if you can read the text there. That top review there, you could hear everybody on the top floor laughing where I work saying, that's the kind of review we want to get. There are some others that aren't quite so nice, but with 4.75 stars, I think we're getting the right indications that we're going the right direction. So in this app, we'll give people reference content so they can hear what a spatial audio experience is. We'll help them set up their device, Xbox or PC, to make sure it's working correctly. And it's just a couple of easy options. So if you want to try it out, I have codes for anybody who wants them. Come down to the Business Center. I'll be happy to give you a code so you can turn this on for free in your own environment. Otherwise, you know, users can just go search for Dolby in the Microsoft App Store, and they're in good shape. They can just go get it for $15 and off they go. Okay, so consumer control. I talked about that before, and I'll keep talking about it. On the PC side, users are presented with a change to the sound taskbar, and apparently that's a pretty big deal at Microsoft. And given the amount of time it took to make this happen, really big deal. But basically, your users will find spatial sound now, and that's kind of this left side over here. You right-click on the little speaker icon, you'll see the spatial audio. You can turn that on, and you can toggle between those modes all you want to. Users can switch between those experiences. They don't have to go back to the source content and get new formats. It is all handled by the system mixer in the app itself. And if you already have surround sound headphones, we can accommodate that as well. You see that checkbox at the bottom for turn on 7.1 surround sound. If you have really good surround sound headphones, turn that off. You might get some interesting and painful double processing that happens, but it will play fine over normal surround sound headphones without the post-processing we apply. On the Xbox, it's pretty much the same look. I just went, oh good, I thought I went backwards. On Xbox, it's pretty much the same thing. You get, changes to the audio control panel again. Users can toggle between the modes that they want to, and, Atmos for headphones or Sonic for headphones as well. They can toggle through HDMI output. This is an old screenshot. Over HDMI audio, you can pick Dolby Atmos for home theater and send it directly to an Atmos endpoint as well. So it's supported for both headphones and for home theater. So to be clear, the headphone experience for Dolby Atmos is $15. The headphone experience for Windows Sonic is free. Atmos for HDMI, free. All that comes for free. The only thing you pay the $15 for is that headphone experience across those devices. And again, notice the third tick box down here. If you have HDMI or optical headphones, we can support those as well. Just let the Xbox know what you're using, and we'll make sure that it gets ported out the right way. So this lets us say kind of cheesy things like no gamer left behind. And as dorky as that sounds, that actually feels pretty good because we're actually able to accomplish the goal of delivering a spatialized mix over headphones and then all the way up to the top tier experiences too. And we think that's a lot more compelling. And it's all pretty straightforward since the gear at home has that bidirectional communication with Windows Sonic. Sonic can just determine the endpoint, send the right output to your home stereo system, to your headphones, and it works without you having to do backflips to turn out multiple mixes to accommodate all the different endpoints out there. And finally, the concurrent spatial and non-spatial audio experiences can still exist. So, spatial audio renders to the full 3D environment and it sounds great, but if you get a Skype call in the middle of that, if you have some sort of notification pop up, the audio ducks as you would expect. You can deal with those non-spatial elements. You can have that conversation, whatever it is. And as soon as you're done, spatial comes right back the way you would expect the whole time. So we feel like the behavior is about right for what we're trying to do. How are we doing? 37 minutes. Wow. Okay, so we should talk about the developer side just a little bit and how you make all this work. Well, if you're already developing on the Windows platform now, this should look pretty familiar. You're using Wasapi, right? The Windows Audio Session API. And in that API, you wrote to an iAudio client. Well, with Sonic, you're writing to an iSpatial audio client now. And so that's the big change. And it's similar to Wasapi. It uses an audio sync. And it supports two different kinds of content now. One is static. That's audio directly mapped to your audio bed. And it's as you did before, but now the spatial audio client has an awareness of additional channels overhead. And so, when you used a PC before with a 7.1 sound card, Wasapi would respond and tell you, I have 7.1 content and a 7.1 output. Everything is great. If it didn't, it would fold down and it would deliver whatever it had to. Well, now when Sonic is plugged in and told I have a Dolby Atmos endpoint, it responds with 7.1.4 over HDMI. So that's 4 channels overhead. Or 8.1.4.4, and that's up to 8.1.4.4, so that sounds crazy, right? That's the usual 7.1 mix you had, an emitter behind your head, 4 overhead, and 4 underfoot. So you can really put people in the dome now. You can bring them into this sphere of audio over headphones and put them into the experience. So you could be done there. You could take your 7.1 mix, you could port it into 7.1.4 and ship a spatial mix and call it good. But Sonic also supports dynamic audio objects, and those are able to be positioned anywhere in the 3D space and moved around as necessary. And that's affected by passing along positional metadata to the receiver. So while Sonic doesn't have anything to do with that metadata, it'll pass it along to an Atmos endpoint. Atmos is capable of ingesting all that metadata and saying this object belongs here, oh wait, now here, now over here, and now back again. So we can position with those height speakers and put things exactly where they need to be. Okay, so objects aren't required, right? You don't have to. You can ship a spatial mix with 7.1.4 all channel based, but they give you a good chance to play around with hero objects and to add some emphasis to light up to effects in your games. So the implementation of all these dynamic objects should be fairly familiar to all of you that are doing Windows development now. It's pretty easy. You create an audio object either in the bed or as a dynamic object, or both. You feed the object's audio buffers every frame, and then you just update the 3D positioning on demand, and it feeds the metadata right down to the receiver. And as your environment changes, you can fly things around. And that's pretty much it. So from here, you don't need to know or care to some degree about whether your user's on headphones or an Atmos system or anything else. You can really trust the system mixer to deliver correctly. But you should probably see that from an engine perspective too. Okay, so here's your typical path today. You've got multiple Wasapi endpoints for lots of different clients, and so I've got game audio at the top in 5.1. I've got a chat client operating in mono, and I've got background music operating in stereo, and all of those are separate Wasapi endpoints. Excuse me. And everything comes together in the system mixer, and it's presented either to your home theater, to your headphones, no problem. So on console, this is a fixed 7.1 mix. And on the PC, you know, the system mix reports back what the output is, formats appropriately. And that's where we are today, but first we should address some of the changes to headphone rendering. Before we had that naive down mix that I was talking about, well, now, both computers, let's see, now that you have a 7.1 surround sound solution, we don't assume anymore that you have a simple stereo output. Instead, we'll poll and we'll find out, you know, do you have a 7.1 mix you're trying to deliver? If so, great, we'll deliver that directly through to the headphones. No changes at all, you don't have to change your mix, user doesn't have to do anything, it just delivers the original 7.1 mix you intended, so it cuts out some of that down mix. Now in this case, you'll notice chat and background music are still down there as Wasapi endpoints. You know, they won't have VSS applied, so chat would sound a little weird if you had VSS applied to that, and your music is probably already created for stereo pretty well. We don't want to mess with that. If you created stereo music, we leave it stereo, and that works fine. But VSS will apply for all your game audio, and it'll sound like the 7.1 mix you intended to deliver over headphones, which we're pretty excited about. But let me move back to the original 7.1 workflow we were talking about before. So how do we change all this to support a spatial audio configuration? Well, it's actually kind of easy. It's that easy. You pretty much use an iSpatial audio client. You present it to the channel bed, and you have a 7.1.4 panner now. So you now have overhead in your control. You can use that and provide overhead positioning as you like. You still have Wasapi endpoints. So you see that we still have a stereo and a mono client coming through on Wasapi while iSpatial audio is working up overhead. They all work fine. They all sum up in the system mix, and they all get passed down to the renderer, in this case, a home theater or AVR, or the headphones, and you know, it's all taken care of by the system mixer. So but just by making the change from an iAudio client to an iSpatial audio client in your engine or middleware, that gives you the awareness of a new expanded channel bed. And so you can fill those as you wish. You can fill those with linear 3D content. You can fill those with with dynamic audio objects. It's your choice. Really, this is a creative tool. We're not telling you what to do with them. But you can do more. But wait, there's more. There we go. You can also feed the mono stems that you have with 3D positional audio, and again, give them precise position regardless of the physical location of the channel bed. So you'd create these dynamic objects. They'd go through the system mix. They go through opaquely because the system mix doesn't have any use for that metadata. However, the AVR does. So the system mix just presents that along down the chain to make sure it's rendered properly in room. And they're mixed into the final 7.1.4 mix in the room itself. So it's a couple of small changes, not too hairy. You know, I shouldn't say that too glibly because, you know, I mean, we fight all kinds of fights to change the software we have in the room, but on a higher level, this is a good way to change to spatial with the minimum amount of work. But okay, what if you wanted to have a different mix based on the endpoint? Like, what if you wanted to change your mix based on whether people are using headphones or speakers or whatever they have? Well, you can certainly do that. You can just query the current output to detect and fire a notification anytime the output format changes, and you can pivot your game audio based on the feedback that you get there. You can do that. You don't have to anymore because the system mix is going to handle that for you, but you can certainly still do that. So none of the functionality you're used to is taken away. We've just tried to make it a little bit easier. There's no runtime changes needed. As I said before, users can toggle and it'll just continue to work on the same mix and render it properly to the endpoint, so there's no lag, no delay, no dropout, none of that stuff. And also, you know, there's no license checks that you have to run against this. So we're not licensing this to game companies. It is not worth it. It's too much work. It's, you know, a great reason not to provide spatial. It's a great reason to say, we're good enough in 7.1, and we think it has enough value that it's worth getting out into the market and get people using it. And we'll make our money off of that $15 app instead. So there's no overhead associated with using the technology. It just exists for you to take advantage of. And so we should address a couple of down mix use cases really quickly where you need to gracefully degrade. For instance, you'll encounter an old version of Windows, something pre-Windows 10, won't know what to do with spatial audio. So, you might be dealing with a user who's opted out. Since we want to allow that, then those surround those surround headphone users may want to opt out, and you want to take advantage, or you want to cater to those guys. So in that case, the system mix is going to come back and say, look, I've got no dynamic objects. I've only got a 7.1 mix available to you, and games will need to have the logic to pull all those things back down to the bed. Now, the good news is you've probably already been doing things like that anyway, so it's just a little bit of a logic change. The better news is the middleware out there already supports this. That's WISE and Fmod, so that's available right now. So you won't lose anything the add to the height plane or any dynamic objects. They'll just be pulled back down to the bed. They may not have the same kind of positional accuracy that you enjoyed before with a full 7.1.4 setup, but you'll still have all the information. It just may not be as precise. Okay. So then, what if you're building your own engine? Is anybody building their own engine in here, their own audio engine, their own middleware? I should just skip the slide, but just in case it becomes important, you can just address the spatial audio APIs directly, or we have a reference panner available on Dolby right now, or at least it should be available on Monday. If it's not, my email address is at the end of this. I'm happy to provide that to you. But I have a reference panner I can give you. It's a C library, and it lets you add, panning to your overall mix, and you can tune and adjust as you wish as well. It's provided as is, so you can just hack away at it all you want to. But again, the good news is middleware is already supporting everything. Fmod and WISE both support Windows Sonic in a variety of ways. Fmod's built in. WISE, there are a couple of plugins out there on the Xbox Developer Network. And if you can't find those, by all means, let me know. I can help you out. I think I've got a couple copies with me right now. So, all right, fine. Let's move on to the typical game audio pipeline out there and how to handle changes to your mix. There's 3 different options that I'll walk through here. And I know we can come up with a lot more combinations of this stuff, but these are the 3 main patterns we're seeing out of most of the game developers out there today. So, as usual, I'll start back with the standard signal flow that we have. Again, I've got music and ambience. How do we say that here? Anyone? Ambience. Got it. So we've got that in 5.1. I've got dialogue and Foley added as mono sounds because what's a talk without Foley? And really today, 3D positioning is handled by panning through the horizontal plane again. I've said that a couple of times. I didn't say immersion, so we got that, right? So the first way you could convert to using Windows Sonic, and maybe the least intrusive and the quickest way to add panning to your game, is to take your 7.1 master and do that. And all that is, excuse me, all that is making it 7.1.4. And so now I'm mastering to 7.1.4, and I need to update my content in the implementation with a new 7.1.4 panner. Your game's already been using X, Y, and Z coordinates, I'm pretty sure. But until now, that height coordinate has kind of been thrown to the side. Yeah, you got height, whatever, we'll throw that out. Well, now that starts to take on some meaning. So some advice there, if you were just kind of throwing things up into space because that's kind of where it belongs, you might get some really strange results out of that. So go back and examine where your emitters are and make sure things are kind of placed realistically. But if you've done that, then you'll get a pretty decent representation of height out of emitters that you've put overhead now. So, this is addressable by global settings in your middleware. You can just tell your middleware globally you have a 7.1.4 panner. And now that you're making everything to a 7.1.4 master, Sonic will take care of mixing that out to HDMI or to headphones or whatever endpoint you've got. And again, naive linear down mix, it's now coming out in VSS to your headphones for free. So this is the least intrusive pattern and the easiest thing you could do. It's probably more work in reality, but this is the simplest flow to take you to overhead panning. But you can do a little more, like for instance, what if I've got my music the way I like it, my ambiance, if you will. I've got it the way it sounds, and I don't want to virtualize that. I don't want to send that into the height plane. Well, no problem. You'll add a submix. So here we're adding a 7.1.4 submix, and we're leaving the 7.1 master in place. And we'll use a traditional Wasapi endpoint for music itself. So it'll be delivered in the usual, 5.1 that it was expected to be delivered there. But then I'll use sound effects and dialogue, and I'll send those through a 7.1.4 panner. I missed a period there on mono. Look at that. Huh. It sucks to hear somebody edit their own slides on stage. Sorry, can't get past them. And so, in this case, the submix is again opaque to the mastering mix. Since it's delivering metadata that the system mix can't deal with, they're both essentially output buses. So you want to keep that in mind. As you're building these things in 2 different output buses, you want to make sure they play well together in the final mix. So a little bit of QA is probably necessary there, but it's a little more work. It's not terribly bad, but it's a little bit more work. But you can make things even a little bit more interesting, of course, right? But wait, there's more. So you could move to dynamic objects across the board if you wanted to, and that's for things like hero object, not across the board, sorry. You could switch to dynamic objects in a very selective way. And this is a way to really accentuate some hero objects. So, for instance, I have sounds that I want accurately positioned all the time. I've got a helicopter, or a flock of birds, or a rock being thrown at my head or something, and I want that to move accurately with a lot of fidelity towards the player or with the player, however it wants, and I want control over that. Well, great. I can do the same thing before. I can send my music and ambiance all the way over to the 7.1 master, no problem, and I can take my mono dynamic objects and I can send them through, I can make them dynamic objects, create them, and send them through the system mix as well, and have those positioned spatially by Sonic. This works really well, and again, those dynamic objects are kind of opaque to the rest of the mix, so you're going to have to manage that on your own, but not the hardest job in the world. What is worse, honestly, is that this works great for a small selection of dynamic objects, but as you start to enhance your mix with 10, 15, 25 voices, this can get pretty complex, and this can get kind of hard to manage as well, and we have some strategies to deal with that, but keep in mind, things get chaotic when you have a lot of dynamic objects flying around the room. Okay, and then it can get chaotic for the user and the developer too when we're talking about it. So to deal with that, co-location is something you've already been doing for a long time. The thing to keep in mind here is that object-based audio isn't just a dynamic object that's one sound. Really, a dynamic object is the relation of audio to a point in 3D space. And so for instance, if you have a character off camera and several feet behind you, there's really nothing wrong with combining those two audio assets into one spot and moving those around. Now, as they get closer, you may have to make the decision to decouple those and spatialize those differently, and your instantiations will kind of inform whether you can do that or not, but it's possible. And this is a great way to manage the number of overall voices you have. It's a great way to reduce the chaos associated with tons of dynamic objects all around. And if you want to try it out, there's some samples on Microsoft where you can just start throwing all kinds of things up in the dynamic objects and see how crazy it gets after a couple of seconds. I think I need to start stepping on the gas here. So I'll summarize here. Migrating to from 7.1 to 7.1.4 is probably the least disruptive way to go through this, and it's the easiest way to spatialize over headphone. But maybe you didn't want to spatialize things like your background music, so you can resolve that instead by building submixes. That's very flexible, and it gives you lots of choice about what you want to spatialize or not, but it's a little bit more work. And finally, dynamic objects that are 3D positioned give you really ultimate control over a couple of hero objects, but it does open a vector for chaos and craziness, again, both for the developer and for the listener. So, hybrid approaches all work as well. Like I said, I'm sure there's going to be 50 different ways to approach this in another year, but these are the three main patterns that we see out there right now, and a lot of the AAA gamers or AAA companies are taking those approaches as well. We should talk about cost. Good news is on Xbox, everything happens in the hardware, so it comes for free, so no real CPU cost there. On the PC, the classic rules apply. You don't know what CPU you're getting, so the number of voices available will scale based on how many cycles, how much CPU is free, and we'll just fetch objects back from dynamic to the bed until we have more objects available based on the CPU. It's a tricky world out there in Win32. But anyway, in the table you'll see here that we have a fixed limit of 32 voices over HDMI, and that's a limitation of HDMI, by the way. So you can still do hundreds of spatial objects if you want to. If you say, I got to have that 33rd voice. Well, no problem. You can do things like co-location, submixes, and things like that to deal with extra objects as you need to. If you think about it, you've been working in 7.1 for a long time. Now you're working in 7.1.4. You're getting a lot more channels anyway. You're getting 32 virtual channels. So you've got a lot of room, but you can still use techniques such as co-location to deal with the chaos if you have to. I will point out that you can use 128 objects in Windows Sonic for headphone, and if you have the strength and the stamina to go deal with 128 independent objects flying around the room, go for it. Haven't seen anybody do that yet, but go for it. And another one, 8.1.4.4, that adds up to 17, not 16. What's wrong with your math, Andy? Well, actually, base is rendered through at a completely different channel. It's cheaper to do it that way. We don't assign that an object-based location. So you're still limited, or you still get the 16 objects in bed with Windows Sonic for headphones. And you should probably keep an eye on file sizes with pre-rendered cutscenes. So you could, by virtue of adding 4 more channels to a pre-rendered cutscene, really increase your audio payload. So manage that, take a look at your file sizes. In reality, compression will help you deal with a lot of that stuff, but you will still have larger files if you decide to do full, PCM linear content in spatial audio. Pay attention to that. How are we doing on time? We got a couple of minutes left, right? Yeah, a lot of minutes left. This is great. All right, so just to emphasize the scope of Windows Sonic and Atmos delivery, this isn't a solution for things like plug-in based features you're using already. This is really just to solve for 3D positioning of audio. So I'd continue using the tools that you already have out there for like Doppler and occlusion and obstruction and things like that and other environmental cues you want to put together. But the presence of additional channels and dynamic objects gives you a lot more opportunity for audio cues like slapback delays and for floor reflections and things like that. You actually get more space to add these effects in so you can create more realistic mixes as you go. And I forgot to change slides there. Sorry, I read that one. Okay, everybody good? Good, okay. So, we talked about 32 voices before. Your game may be hundreds of voices, and while that may sound off-putting at first, there's a distinction here. You're getting 32 virtual channels, not voices. So I talked about you're already working in 8 channels. Now you get a 4x upcharge or an upgrade to the number of channels you have. Plus, you get hero objects with dynamic position as well. So you're not limited to 32 voices, you're limited to 32 channels. And so you can use those as you wish. If you're still running into limits, collocation, culling, submixes, don't forget to use those as well. We talked about limiting overhead objects to maintain, kind of a coherent mix and drop some of the chaos out. That still applies. Talked a little bit about how LFE content doesn't localize very well at all. You may have a case where you need an LFE element overhead. You might, and it might sound great. QA that pretty carefully because that can give you some kind of weird effects. LFE really is just kind of occurring in the room and it's hard to spatialize, so listen to that very carefully. One of the big ones is locales of confusion. So you guys know this, there's that plane down the middle of my head here that represents my performance review every year, that if you put an audio object anywhere along that plane, it's kind of confusing. It's overhead, but I don't know where it is overhead and I can't figure that out. So if you want precision in that, bias it a little bit to the left or the right, people will pick it up. If you want confusion, if you want to have a true God voice that I'm not sure where that's coming from, that's a great place to put that. But now that you have access to an overhead channel, these are things you're probably going to have to consider just a little bit in QA as well. Finally, music. I talked about Overwatch before, and it seems like I'm just in love with that game because I am. It's not because I'm good at it. It's really because the things they've done in that sound mix are pretty amazing. You should give it a listen if you can. The way they deal with music is just amazing. They've pulled things back from the front channels. They've pulled everything back and into the height, into the background a little bit. And what you get is this great larger-than-life experience in that game that really feels like you're in the middle of it all, which with it being such unreal content, it's kind of strange, but you feel like you're living in the moment in that game. And I think the music has a lot to do with that. I think the ambiance they create behind your head and above your head has a lot to do with that as well. Not only that, it gives them lots of room for subtlety in sound. It gives them lots of room for like little small, minute cues that they can put right up in front of the user and dialogue comes through really clearly. So again, play Overwatch, give it a listen. It's amazing. All right, great. So you want to start today? Fantastic. Well, what do? Well, start with your headphones. You've got a set of headphones. You've got a stereo output. Just plug it in. You're good. Light up Dolby Access. Get a code from me. It's for free. And see what you think. And if you want to try this out, we have a demo down in the business center. Just make an appointment with me or I'll come out and find you. Bring your headphones. Use my headphones. Come and give it a listen. Really, it sounds pretty incredible. That's the easy path. If you're using speakers, it's a little bit more work. So make sure that your PC supports HDMI 1.4. Most mini display ports like you have on your Macs are 1.4 and higher, but check your documentation to be sure. And then, you need an Atmos capable AVR. And for mixing and for your studios, we'd recommend 7.1.4, mainly because that gives you the full spread overhead. That's our reference implementation right now, and the 4 overhead channels give you a lot of precision during mix time. And this is where we come back to that ceiling mounted speaker thing. Yeah, use ceiling mounted speakers. Upward firing is great for home. It's great for gameplay. You don't get quite as much precision as you want during mix time. If you want to know where something is while you're working, overhead is the way to go. So put the bite on your studio folks now to put speakers overhead or when they have budget. And then I think the only other thing to really mention here about prepping your studio is that, QA. Great. So I have to have QA folks actually go and rip out what they have and start over with another mix. Well, what we see people doing is that people are taking their high-end consumer room and they're tearing out the 5.1 stereo system that they have, putting in 7.1.4 and leaving everything else in place. They'll give one good Atmos listen through. They'll do kind of a low-end home theater in a box setup, whether it's stereo, 7.1, 5.1, whatever they're comfortable with, and a headphone listen, and you should be good at that point. We're so confident with the fidelity of the throughput to all those endpoints, you should be getting a very consistent experience. If not, let us know. So it's not all that different. You're going to need some extra gear, but you're going to have some great movie nights in the office after that. So, good. So, all right, great. Where can I find out more? Well, Windows Insider program. If they don't push it towards Windows somewhere, then what am I doing? They have lots of samples. They have lots of documentation. I talked about that demo app they have before. Download that and play with all the dynamic objects and see where it gets to the point that you just can't handle it anymore. It's interesting to see that there is a defined limit in your head somewhere about how many things you can track at one time as a dynamic object. Start there. MSDN has a great talk that I admittedly stole some slides from for this. On their Channel 9 video list as well, it's presented by Scott Selfon, and he does a much smoother walkthrough on this than I do. And you can hear this today. Come on down to the Business Center, and I'll give you a headphone demo all you want. I even have Overwatch on that machine, although the network doesn't really support that, so you may or may not get to hear that. But come down here if you want to, and I'll be there to answer any questions you've got. And if you can't make it today, or if you wake up at 3 o'clock in the morning in the cold sweats and you have a question, don't call me. Instead, come to developer.dolby.com. We're about to roll out our new website, so if you get a 404, call me. But we have a lot of tech details there. We have a lot of sample content, a lot of streams, a lot of test streams, a logo program, so when you're done, you can slap the logo on the box. We have studio setup advice. We can set you up with our studio gurus so they can walk through your architectural designs and tell you what works and what doesn't work and how better to set things up. And we're spinning up forums and stuff, so you can hit us with your opinion, positive or negative. That's all good. If all that fails, hit contact us. I'm us. So, send me an email. Let me know what you like. Let me know what you don't like. I'm andy.vaughn@dolby.com. That's VAUGHAN. If you skip that extra A, I don't know who it goes to, but it certainly doesn't come to me. I should set up an alias for that. Anyway, that's what I've got. Thanks everybody for coming. I really hope that we get to see some spatial audio out of you soon. Thank you. If you want to come see a demo, by the way, whoops, there's the information. Just fire open the conference app, book an appointment with me. I'll accept any appointments that come at me. Come down and we'll give you a demo, okay? Questions? Anybody want to throw something at me? I said immersive like 4 times.
Yeah, sure. You talked a lot about the support and compatibility of Windows platform, Xbox, but you didn't talk about the PlayStation platform compatibility. Is it something we could expect to have eventually, soon? And with the PSVR platform also, it will be nice to have the ability to ship a game and be compatible with the same multi-channel technology on all of them and not having to support different
Absolutely, yeah.
tech.
We're in violent agreement here. I don't have anything to announce about PlayStation right now, but we have some great conversations happening with them. They clearly have their own spatial audio solution, but they're listening. We've had some very good meetings with Sony. So I expect that we'll have some good news for you in the coming year, if not the next couple of years. Things can move kind of slowly given the flow of content titles, especially right now. But do know that we're pursuing aggressively getting into place with PlayStation as well, because as you say, and you're absolutely right, we want this to be implemented in a very uniform way across all of the consoles, not just one.
And it's a huge time saving.
A massive time savings. Yeah, the most uncomfortable part of my day is telling somebody, yeah, you're going to have another mix for PlayStation. Sorry about that. We're just getting started now. Cinema's taken us this far. We've gotten the first couple of pieces in place. Sony's the next stop for us. Sony will tell us when we're in place, but know that we're proceeding to push on that as much as we possibly can. Yeah. Anybody else? Okay, I guess we're done. Thanks, guys. Enjoy lunch.